So this video is going to be on Friday's classwork 8.42, worksheet part 1 and part 2. I know we didn't get a chance to get into it, so I also want to make sure that everyone understands this, and if you have trouble, you can watch this video and hopefully it'll help you out. First thing I want to talk about is what we discovered when we were doing the infinitely many sided polygons. So as the polygon sizes, we get infinitely many, it becomes circular looking. And as we were finding the perimeter of those and the area of those, we noticed that we ended up with 3.14 for our area, and we ended up with 6.28 for our perimeter. So if we have a circle of radius 1, okay, a circle of radius 1, we are going to get, okay, for a circle of radius 1, we are going to get our area. Here, let me make this slightly bigger. Okay. We are going to get our area. Well, here, I'm going to start with the circumference first. So our circumference was equal to, again, 6.28, which is 2 pi. And let me get my pi over here. Okay. 2 pi. So that is our circumference of a circle of radius 1. Okay, circle of radius 1. Okay. Now, if I'm going to be doing the area was equal to pi 3.14, again, for a circle of radius 1. Okay. And what that means is that all circles, let me just get out of this, all circles are similar. So if a circle of radius 1 has a circumference of 2 pi, then a circle of radius r, which is r times bigger, my circumference, which is like perimeter, is also going to be r times bigger. So if I take this, I'll move it over here for this one. So my circumference is going to be, what was 2 pi, now it's 2 pi r. It's r times bigger. Okay, just like perimeter, circumference is going to be times by what you're multiplying it by. In this case, it's my radius r. Over here for the area, remember that area is not going to be r times bigger. Hold on, sorry, I want to grab this one. It's not going to be r times bigger. It is going to be r squared times bigger. So my area for my circle of radius r, again, with that being r times bigger than this circle, it's not r times bigger for area, it's r squared times bigger. Okay, so this circumference equal to pi r is going to be my circumference of a circle. This area equal pi r squared is area of any circle. And I'm going to write this one here in a different way. So circumference is 2 pi r, where 2r is 2 times your radius, your radii here. And here, your diameter is equal to 2 radii together. So instead of this being 2 pi r, I can instead think of it as, get rid of that, don't need that way, as pi times diameter. Okay, so again, you have 2 pi times radius or pi times diameter. These are the same for circumference, and then your area is going to be pi r squared. So now let's get to the actual work. So I put up here on this, the area of a circle is pi r squared, circumference is 2 pi r, and circumference is also pi times diameter. So in this problem, to celebrate their victory, the girls' ice hockey team goes out for pizza. The goalie eats half of a pizza that has a diameter of 20 inches. what is the area of the pizza that she ate? So let me get a circle. And remember, if you're going to do a circle, you're going to hit shift so it stays an actual circle and not an oval. Okay. And then let me draw in, this was a diameter, so it's going to go all the way across. And the diameter of this was 20. So 20 all the way across. Here, I'm going to make that. Okay. Now, in this case, it's asking what is the area? And again, she ended up eating half of the pizza with a diameter of 20. Okay. And we want the area. So we are going to know that our radius is going to be equal to 10 because that's going to be half of my diameter. And so my area of the whole entire circle is going to be 100 pi. Here, so I've got my, can use my pi. It's going to be my area of my whole entire circle. It's going to be 100 pi. And I don't have the whole entire circle. I mean, well, a whole entire pizza, I should say, right? We have half of it. So the amount that we have, okay, is going to be half of that. So I am going to basically be taking half of 100 pi, and half of 100 pi is going to equal 50 pi. Okay, and that is going to be, here, let me just highlight it. So we can see that, okay. And so that is going to be our answer for this, and here, I'll move it over here. Now, that is the area of the pizza she ate. It says, what is the length of the crust that she ate? So the length of the crust, okay, we're looking, for example, here, okay, to see what this is, okay? So that is going to be circumference, okay? And so circumference, I'm going to be using this pi times diameter since I know my diameter, okay? And so this is going to be circumference of the whole entire thing is it going to equal basically 20 pi, okay, 20 pi, get my pi. And I don't have the whole entire crust, right? So the crust is that circumference. We have half of it, okay? So we are going to be taking half, okay, 1/2. And I know we can just do this in our head, but I want us to think about this when we're doing the next problems, of 20 pi. And so half of 20 pi is going to equal 10 pi. And that's going to be our answer. Okay. And oops, let me highlight. Okay. And so that's going to be our answer. Now, when we get to the next one, Sonia chooses a slice from another pizza that has a diameter of 16 inches. If her slice has a central angle of 45 degrees, what is the area of her slice? Okay, so this one I think we could understand that, hey, okay, find the area, it's going to be half as much because she ate half the pizza, or the crust. If we knew the whole crust, which is the whole circumference, we're going to have half of it. This one's a little different. We're talking about 45 degrees here. Okay, but it's going to be similar. So here, let's have our pizza. And this one is a diameter of 16. Okay, so diameter of 16 for this one. And we know that the piece that she had was 45 degrees. Okay, so I'm just going to visually show us. Let's say I'm starting here. Okay, and you can actually kind of see that it is doing the angle here. Okay, so 45 degrees. Hold on, let me get started here. 45 degrees. I'm looking at the bottom angle here. Well, it should be 45 and 45. I don't need to do it perfectly, but you can get those angles. Okay, so let's pretend that I got it to 45 degrees, okay? So 45 degrees here. So we have 45-degree angle, 45 degrees. Let me get my degree. I'll do it this way. If you just need a math text box anywhere, just hit 7 and it hasn't done anything, but if I click, I'm now in the math mode. And so I can do 45 degrees, okay? And get my degree symbol. Okay. Let me get back into my text box, sorry. There. And I can make this smaller. Okay, try one more time. Here, make it smaller. Okay. And so that's my 45 degrees, let's say. Okay, so she is eating this portion. Okay, let me kind of shade. She's eating this portion of the pizza. Okay, that 45 degrees. Okay, now we're still going to figure out the area. Okay, and area equals to, I'm going to write it now. So area is equal to, for the whole thing, if my radius, my diameter, sorry, this is my diameter is 16. That means my radius is going to be 8, okay? So I'm gonna go pi r squared, 64 pi would be the whole entire pizza, okay? That would be the whole entire pizza, but she only ate 45 degree angle, okay? And so what I'm going to do is I am going to figure out what part of that. Well, she ate 45 out of 360 degrees. 360 would be the whole entire circle. She ate 45 degrees out of that 360 times 64 pi. And then I'm going to put that into my calculator. I'm going to leave it with the pi. So let me just put that in. So when I got my answer and I did that math, I ended up with 8 pi as my answer. Okay, that's the area of the slice that she ate. Then it says, what is the length of its crust? How can you calculate, show how you calculate your answer. So now, again, if we're talking about the crust, we're talking about this right here, okay, that much. And so I'm going to be dealing with circumference. And circumference is pi times diameter, or 2 pi r, but I'm going to use my diameter 16. So 16 pi here, hold on, let me write that better. Okay, is equal to 16 pi. And again, I don't have the whole thing. I have 45 out of 360. Again, that can be reduced, but I'm just showing you how I'm getting that 45 out of 360. And when I do that math, I end up with 2 pi as our answer. Okay. So now, as the evening draws to a close, Sonia notices that there is only one slice of pizza, one slice of the goalie's pizza remaining. Remember, the goalie's pizza was 21-inch diameter up here, okay? So this had been going all the way across 20-inch diameter. She estimates that the central angle is 72. Using this estimate, what is the area of the remaining slice? So again, the area for this is going to be radius 10, since our diameter is 20. So that would have been 100 pi, would have been the whole pizza. There's 72 out of 360 left times 100 pi. And when I do that, I end up with 20 pi as our answer. Okay, that is the area that's left over. Now circumference, again, circumference, okay. So we're looking at this crust, okay, is the length of the crust, is the circumference. So my circumference from this, if my diameter is 20 pi was the circumference of the whole thing. And again, we have 72 out of 360 times that 20 pi, okay? So when I do that math, I end up with 4 pi as our answer. Okay, 4 pi is our answer. Now, next question. It says a portion of a circle like the crust of a slice of a pizza is called the arc. Okay, so this is going to be important here. Okay, so a portion of a circle like the crust of a pizza is called an arc. Okay, this is a set of connected points, a fixed distance from the center point. The length of an arc is part of the circle's circumference. Okay, so I'm just going to highlight this. The length of the arc is a part of the circle's circumference, just like I was doing before. If a circle has a radius of 6, what is the length of the arc with a central angle of 30? Okay, so in this picture, I know that the radius, they said, here, let me draw it actually to where this arc is. So we're going to be having this piece right here, okay? The radius is 6, and I know that this angle here is 30 degrees, okay? That's that angle here. And we want to know what is the arc length, the length of the arc. We call it arc length. And so we are looking at this right here that I'm doing in blue. That's what we're trying to find. So when we're finding arc length, we're going to find the circumference, okay, which is 2 pi r. So 2 pi r. So that is going to be 12 pi. We don't have the whole thing. We have 30 out of 360 times 12 pi. And so when I do that, I end up with 1 pi. Okay, 1 pi is what I ended up with. Now on the next one, it says a region that resembles a slice of pizza is called a sector. Okay, so here this is a sector. It's like a slice of pizza. It is bounded by 2 radii, okay, of a central angle and the arc between their endpoints of the circle. If a circle has a radius of 10, okay, radius of 10, what is the area of the sector with central angle 20? Okay, and again, here's a new word we want to understand, sector. Okay, so sector, this is a sector, it's a part of a circle, a slice of a circle. And this one has a radius of 10. Hold on, let me grab a pen. Has a radius of 10, okay? And this angle here for us is a 20. Okay, 20 degrees. Try to squeeze that in there. And so this is going to be area is equal to pi times radius squared, which is going to be 100. So that's going to be 100 pi. And then I have part of it, okay? So I have 20 out of 360 times 100 pi. And so when I work that out, I end up with a decimal, okay? But if I change it on my calculator to fraction, I end up getting 50 over 9 pi. So 50 pi ninths is what I end up getting, okay? Just keeping it as the fraction. Don't change it to a decimal. On 89, it says, it is useful to be able to calculate the area of a sector for any circle. Work with your team to derive a formula by doing the following tasks. Look at your work from problem 8-88 and describe the relationship between the area of a sector and the area of the full circle. So in this case, so it's going to be basically the angle, okay, that you have of your sector out of 360. It's going to be that part of your area, and area is pi r squared, okay? So here they're asking us to write a generalized formula. I actually wrote it above, okay? Here I wrote it. Let me kind of clean it up. So again, it's going to be theta. I'll just write it here, put an arrow here. So it's going to be this theta. Let me grab a highlighter, box highlighter. Do it in green. It's going to be this theta over 360. So your angle over 360 times pi r squared. Okay, so that is going to be the formula for area of a sector. It's just area times the fractional part you have. And the fractional part we have is the angle you have out of the whole entire circle, which is 360 degrees. Now it says use the sectors in circle D and E to answer the following questions. What is the length of the marked arc for each circle? Leave your answers in exact form, that is in terms of pi, okay? So for D, we have, and we are looking for the arc. Okay, hold on. We're looking for the arc. So we're looking at the crust basically here and the crust here, okay? So if I'm looking at D, okay, for D, this is for D, and I'm looking at the crust, the full, so I'm gonna have 30 out of 360 times my circumference, which is going to be 2 pi r, okay, which is 6 pi, so this is going to be 6 pi. I'm going to clean that up, so when I do that math, I end up with 0.5. I'm going to leave it as 1/2 or pi halves is what I ended up getting, okay? Now for E, let me do that in pink. I'm actually going to do it right over here. So for E, I also have 30 out of 360. This time for this circumference, it's going to be 2 times pi times 5. So it's going to be 10 pi. And so when I work that out, I'm going to end up getting, as a fraction, 5/6. Okay, I'm going to write it as 5 pi 6. That's what I ended up with. Okay. So then it says for circle D, what is the ratio of the arc length to the radius? Arc length to the radius. Okay. So my arc length was pi halves. My radius is 3. So what they want me to do here when they say ratio, I'm going to have a fraction basically. So I'm going to take my, grab my pen. I'm going to take my pi halves over 3. That's what I'm doing. Okay, pi halves over 3. And when I take pi halves over 3, that's the same as pi halves. Since I'm dividing it by 3, I'm multiplying it by 1/3, and I end up with pi 6 as that answer. Okay, over here, this one was pi halves, this one was 5 pi 6. Okay, now it says, and for circle E, right, what is the ratio of the arc length to its radius? Leave your answer in pi. Okay, so this time I'm going to do the 5 pi 6 and the 5. Okay, so let me do that one. I'll do that one in pink. Okay, so again, it's going to be 5 pi 6 over my radius, which is 5. So that's going to be 5 pi 6 times the reciprocal. Since I'm dividing by 5, I'm multiplying by 1/5. I end up with 5 pi 30th, which, that's a 30th, which reduces to pi 6. So you notice that this one's pi 6 and this one's pi 6. They're both pi 6. So it says, suppose you have circle F has radius 100 units and an arc with a central angle of 30. What is the ratio of the arc length to the radius for circle F? Show your work. Okay, so in this case, I have a radius of 100. So that means my circumference would be basically 200 pi, because I have to double my radius times it by pi. The part that I have is, again, all of these are 30 out of 360 times 200 pi. And when I do that math, okay, 30 times 200, dividing by 360, I'm leaving the pi out every time. So I got a decimal. I'm going to change it to a fraction. And I ended up with 50 pi thirds, 50 pi thirds. So now they want me to do the same thing I did here, where I take the arc length over the radius. Okay, so let me do that in a different color. Okay, so I'm going to take my arc length, which is 50 pi thirds, divide it by my radius, which is 100. Okay, and I am going to get basically 50 pi. And what you'll notice happens is the 3 and the 100 are going to end up together on the bottom, because I'm dividing by 100, which means I'm multiplying by 1 over 100. And so I am going to get it when I reduce this, 50 over 300 is going to reduce to, if I put it in my calculator, it's going to reduce to pi over 6. Again, so every single time I ended up with pi over 6. Now you have to remember that circles are similar. So every one of these ratios, no matter how big I make it or small, is going to reduce down to the same thing every single time, okay? So on E, it says there are other units of measures besides degrees that can be used to measure an angle. For example, the radian measure of a central angle is the ratio of the arc length to the radius of the circle. Why will all arc lengths with central angles of 30 degrees have the same radian measure? Okay, so here I'm going to mathematically just do that. So I know basically that my circumference for any circle is 2 pi r. In this case, I have 30 out of 360 of that. So when I clean that up, I'm going to get 60 pi r over 360, which actually is going to simplify to pi r over 6 when I do this math, okay, and I simplify it. Now, when I take that and I do this arc length as a ratio with its radius, I am going to get pi r over basically 6r. And you see that my radius on top and bottom is going to cancel out. And I am going to get, again, pi over 6 every single time. Every single time. Now, I'm going to pull up something to show us what this is going to become for us here second semester when we start getting into the math analysis and talking about unit circle and trig. So give me a sec to get that up. So what I have up on the screen for us right now is called a unit circle. And a unit circle is a circle of radius 1. So you'll notice that this point is at 1, 0. We're starting at the origin, 0, 0. And as it goes out, this point's 1, 0. This point up here is 0, 1. This point over here is negative 1, 0. And this point down here is 0, negative 1. So this is a circle of radius 1, okay? Now also, let me get rid of these. If I was to go all the way around the circle of radius 1, okay? Pretend I could actually draw all the way around the circle to radius 1. As I get to here, okay, this is pi. As I get all the way over here, this is going to be 2 pi. Okay, they didn't write that here, but this is 2 pi. And that was the circumference we found for a circle of radius 1. All the way around the circle, again, let me do it one more time. All the way around the circle, all the way around the circle. This is pi to here, that's half of a circle of radius 1. All the way to here is 2 pi, okay? Now, if you look here at this 30 degrees that we were just talking about in the problems, that 30 degrees has a 2 pi, I'm sorry, a pi 6 right there. Okay, 30 degrees is pi 6 of this circle, okay? Because if I was to take 2 pi, which is all the way around the circle, okay? And I basically have 30 out of 360 of it. I end up with 60 pi out of 360, which I can reduce to pi 6. So eventually we're going to start talking about radians, okay, which is what I always say, make sure your calculator is not in radians, but we're going to be talking about radians, and 30 degrees and pi 6 are the same angle relationship here. 30 out of 360, pi 6 would be, you'll notice that we have a sixth of pi, okay? Because if I took 180, which is all the way to here, and I divided it by 30, I would get 6 equal pieces. There are 6 pieces that would each be 30 degrees. And so I have one of those 6 pieces, pi 6, okay? So that's where that ratio is coming from. So again, this pi 6, for a central angle of 30 degrees, my arc length, the part of the circle that I had, was pi 6, whether it was r as my radius, 100 as my radius. Over here we did 3 and 5. Every one of these, when I took the relationship of the arc length to its radius, ended up being pi 6, okay? Now I'm going to talk about the second worksheet. And I'm actually going to do this in a second video so that we have one video if you just want to focus on the first one, one video if you want to focus on the second one. So that's the end of this video.